This one, is it compound interest? Continuous interest? What type of interest is it? Why? How do you know that? It tells you that, yeah. Continuous interest is actually a type of compounding. How often is it compounding? Every what?
Unit time of time.
Every instant, yeah. That's about as specific as you can be. Every instant, because it's every infinitesimally small unit of time. So, what formula are we going to be using? A
equals P times E to the power.
Yeah, exactly. It needs an equal sign. That's the formula we're using. Okay. So your principal is $200. E, what's your, oh, what are you trying to solve for in this equation? R. And how many years is it? And it equals what? 379. So, did we plug in correctly? What do you think? What? Yeah. You're going to have to use your calculator to finish this. So how do we go about doing this? Yes. Divided by 200. Like that. Correct? Now, this is an exponent form. Let's translate it into. So it's going to be log base E of what? Log base E of what?
370.
Yep. Over 200 equals what? So R is equal to 1/8 ln of 379 over 200. So that's going to be 0.125, that's 1/8, times ln of 379 divided by 200. So, what does that tell us the interest rate is?
About 8%.
Yeah, it looks like it's almost exactly what? Yeah, when you get an answer like that, I mean, you could, if you're going to round to two decimal places, you would say it is 7.99%. So about 8%. The person probably made this question up by doing it at 8% and then just deleting the 8%, like figuring out how much money you'd have. My guess is it was 379 point something dollars, and it was less than 1 cent above, so it rounds to 8%. Does that make sense, everybody? Yeah, so you need logarithms to finish this money problem. Good pick. Who wants to raise their hand and give us a second one to do? Over here. On the first page. Sorry, let's stick with the first page. Yeah, which one? Which one is it? Oh, right here? 7? Sure. It's a good one. Do you remember what effective interest means?
Yep.
Can someone explain it to me? What is effective interest, Victor? Yeah, it's what it would be if it was once a year. Yeah. What would it be if it was once a year? So in this case, I'm assuming this right here is 6 3/4%. Is that what you guys understood it as?
Yeah.
Compounded quarterly. Compounded quarterly. So that means you're dividing by what? 0.0675 over 4 raised to the what power? 4th. Essentially, it's figuring out what would you multiply this by. So in the formula, if you were going to take a sum of money and compound it for a year quarterly, you would multiply it times this, correct? If something grows by 5%, what do you multiply something by to grow it by 5%?
1.05.
Yes, 1.05. Very good. So the effective interest rate would be 5 in that case. So what do we actually subtract from this? I already wrote it up there. 1. The effective interest rate will be this right here. The effective interest rate will be that right there.
Last time you wrote the formula as 1 plus R divided by N.
This is N.
And the power is N times T.
That's correct, but you're only doing it for 1 year. Effective interest rate is what would be the interest rate if it was once a year? Yes.
So it's always
the effect, yes, once. Effective interest means what would the yearly interest rate if you did it once a year? So think if you compound something, the more you compound, the more money you make, right? The more you compound, the more money you get. So 6 1/4%. If you compound that, should you have a higher effective interest rate or lower than 6.25%? Higher than 6.75 or lower than 6.75? Does it raise the interest rate to compound or lower it? Yeah, you make more money. You make more money than you would if it was once a year.
Effective rate will be higher.
Exactly, the effective rate will be higher in this case because you're comparing it to 6.75% once a year, or dividing it into 4 and doing it 4 times. So if you do this out on your calculator, 0.0675 divided by 4 plus 1 raised to the what power? 4th minus 1 times 100. And you end up with... Exactly. So is the effective interest rate higher than 6.75?
You don't need to write t, you just write to the power of n.
Yeah, that's fine. Yes, but it's t is 1 in this case. It doesn't really matter. Either way, any way you want to think about it, it's fine. So in this case, the effective interest rate is 6.92%. Does that make sense? Yeah. Okay. So 16 log base 2 of 5 to the x equals, what do you want to do on the other side? Yeah. What cancels? Mm-hmm.
Log base 2 of
Like that. Now what? There's only a limited number of things you can do. What do you want to do? Only a limited, like 5 things you can possibly do, so pick one of them. What do you want to do? Nope. Can't divide. 25 is 5 squared. Now what can you do? Log base 2 of 5 to the x equals log base 2 of 5. What can you do with that 2 that was up there? Move it in front. Now what cancels? So you have log base 2 of 5 to the x equals log base 2 of 5, so x is equal to 1. It's a good question. It's good. Are there other paths you can take to solve this? Yeah, there are. There are definitely other paths. What do you notice about this log problem? What's the first thing you notice? And not only are the bases different, what else do you notice about them? It's not that, yeah, what specifically about factoring? They are not what of each other? They're not what? They're not nice powers of each other. So is the answer going to be nice or ugly?
ugly.
It's bound to be ugly. What are we going to have to use? Change a base form. We don't have to use double. We don't have to use it twice. What base do you want to keep? 6 or 4? 4. So this turns into log base 4 of x over log base 4 of plus log base 4 of equals 3. Now what can I do? Shh, one at a time. We could do a common denominator. Let's see if we can do it even shorter than that. What's in both of these? What? So factor it out. Log base 4 of x times what? 1 over plus what? Equals. Just for notational purposes, let's just call this, right? Is that a number? Let's call it, not n, let's call it g. So what do we have here? We have g times log base 4 of x is equal to 3. What should I divide by? Log base 4 of x is equal to, that's in log form, what should I translate it into? So what does x equal? 3 over g. Yeah, exactly. Can you do that numerically if you want? Could you punch that into your calculator to get a number? Sure. But that right there would be a completely acceptable answer. Do you see why it's helpful to write g, like label that thing as g? It's helpful. You don't have to write it. It makes it that would be about twice as big if I didn't do that, because you'd have to write that bigger parentheses thing several times. Again, are there hundreds of ways to do these? Yes.
Yeah.
Many different ways to write the same thing with logarithms, and it's not obvious. One of the hardest things I have to do is when I grade logarithm questions, you guys will come up with new methods of solving, and I'll have to sit there and figure out if it's the same thing, and it's really annoying. So I try to show you guys the nicest methods to kind of keep you on a as flexible a narrow path as possible. Okay, let's move to the third. If you want to pay $1,000 for a house over a period of 20 years with 5% interest rate compounded yearly, what must you pay per year? You want to pay for a $100,000 house over a period of 20 years with a 5% interest rate compounded yearly. So the way this question is written, is this interest rate working for or against you? Against you. It's not 100% clear, but it's working against you. So you're, do you remember the formula you're going to have to use?
You're gonna have to A equals 2 parentheses on I multiplication of I and then divided by on 1 plus I and 1.
You use that formula only when it's working against you.
When you have a loan and it's working against
okay.
you. When you're paying back a loan.
And the one that you don't, it's just...
It's different. The other one, let's just leave it at the other one for now. The other one is going to be for when you're putting money into an account that's earning interest.
Okay.
It's a different situation. You're starting out with nothing in the account, you're adding into it. Yes?
That one is earning and this one is to pay.
This is paying off a loan. Yes, that is correct. So so for this one, it's as simple as plugging in the right numbers. And again, Stan, this is what you talked about at the beginning of class, is plugging in the right stuff, right? So what's the starting principal? 100,000, yep. In this case, I is the interest rate divided by, no. Oh, it's compounded yearly. So what is it just? 0.05 over what? 1. Yeah, very good. Yeah. And then it's going to be 1 plus 0.05 over 1. And n in this case is, what is it? 20. All over 1 plus 0.05 over 1 to the 20th minus 1. So the trick to this one really is writing that, and then the second hardest thing to do is going to be 100,000 equals A times 1 minus 1 plus, what is I in this case? Yeah, because you're dividing it by 1. What power are we raising it to? Close. Remember the last thing? What do you, yeah, it has to be 21. Yeah. Over what? 1 minus 1 plus 0.05. Excellent. Okay, so what does this tell us? If we want to have $100,000 in our account after 20 years, how much should we put in each year? So, yeah, so let's multiply this times 20. So you put in $55,992, and at the end of the 20 years, you end up with $100,000. You're almost doubling your money, almost. Is this a pretty long-term plan? It's an extremely long-term plan. It's an extremely long-term plan. Excellent.
But why is 20?
Because that's the formula. We talked about it yesterday. We derived the formula, and I'm not going to do it again. If you want to come in after school, it's 1 more than the number of payments. And is in this formula, and is 1 more than the number of payments. And you can go back and look at the video from yesterday if you want the proof. Changing the base of logs. You all should just have in rote memory, you should know log base A of B is equal to log base C of B over log base C of A. So what does this mean? This means that log of 5 over log of 2 is the same thing as ln 5 over ln what? 2. Same as log base pi of 5 over log base pi of 2. Doesn't matter what the base is as long as it's the same on the top and bottom. That's all you need to remember. And when you have different bases in your equation and you need to solve for something, you're almost guaranteed that you're gonna have to use this. Yes.
So if you have different, if you change the base and you were adding the logs together, so you have like now fractions and you have log taking 10 of x over
log 10. So log of x over what?
Over log of 6.
Yep.
Plus log of x over log of 4.
Yep.
Can you just do log x squared over log 24 squared?
Nope.
So you do have to.
They're fractions. So what do you have to have? You have to have a common denominator. You must have a common denominator. Yes, exactly. You could, before you do that though, you could factor out log x and make it log x times 1 over log 6 plus 1 over log 4. But you still need a common denominator to add two fractions. You always need a common denominator. So in this case, it would be log x times log 6 times log 6 plus log 4 over, what's the common denominator going to be?
Log 6
Times log 4. What's the one thing you can simplify inside the parentheses? The numerator or the denominator? Which one can you simplify, the numerator or the denominator? Yeah, what does it become? Log of? Can you do anything to the base? Nothing worthwhile. You can make it you could turn it into, you can make it log of 4 to the log 6. Is that going to make it look more simple? No. No. But that's as compressed as you can get it. We've taken separate logs and we've compressed it into one nasty log equation. Well, one statement. You can't do anything else to that. Okay, another question. Something else you want to ask me? You're also supposed to come up with 2. Yes?
I still so confused about.
So you have these 3. That's when you make one deposit and you let it sit there. That's when you're saving money, but you are continually... Yes, exactly. Exactly. And on this one, you are paying off a loan. So the interest is working what? Working against you in this one. Unless you're the bank. Banks aren't doing so well anyway, but I guess they are. Who knows? They're making more money than ever. I don't really understand that.